In this video we're going to look at the sine rule, sometimes known as the law of sines, which is a very simple rule to remember because all you need to know is that if you've got a triangle ABC, and if you've labelled the sides correctly, that is that if side A is opposite angle A and side C is opposite angle C and side B is opposite angle B, then this rule down here applies. So A, that's side A divided by sine of A is equal to B over sine of B equals C over the sine of angle C. You can flip that those fractions upside down if you like to get this thing here. And it's fairly easy to use. Right? So if you want to solve this triangle here, it's relatively easy to do it because what we need to do is to do A, the side here, divided by the sine of whatever this angle is, equal to this side here, B, divided by the sine of angle B. It's a little bit more difficult in this example because we don't know what this side here is yet, but it's reasonably easy to get that because we know that if we add the two other angles up and subtract them from 180, we should be able to get that angle. So angle A, the angle that's missing, is going to be equal to 180 minus 81 minus 38. So all we're doing is we're subtracting these two angles here from 180 because the angles in a triangle should add up to 180. And we're doing that and we'll get this angle down here. So I hope that then gives us 61 degrees. Okay, now that we've got angle A, we can now use the sine rule. The sine rule is going to be 6 divided by sine of 38. So again, that's this side here, 6 divided by sine of 38 degrees, sine of the angle. And that should be equal to C over sine of 81. So that's equal to C, this side here, over sine of 81. And then it's possible then to solve that for C. We just rearrange it so that we can find out what C is equal to. If you do that, we'll get 9.6256. So that gives us side C. If you want to get the other side, side A, it's not too difficult. We have to do the same kind of thing again. We this time do A divided by sine of A, whatever this angle here is. We figured out that it was 61, so A divided by sine of 61 is equal to 6 divided by sine of 38. Okay, and if we solve that, if we rearrange that, what we should get is A equal to 8.5237. Okay, so finding a side is a reasonably easy thing using the sine rule. Sometimes, however, it's one of the angles that we need to find. Perhaps we just have one angle and we need to find one of the other angles if we've got two sides given to us. Now, there are some complications when we try to do this. If you end up with sine of an angle equal to a number like this, 2.3, or any number that's bigger than 1, then there are no solutions. When you do the sine rule, your answer, the sine of the angle should be equal to a number that's between 0 and 1. So 2.3 is no good. If the sine of the angle is equal to 1, well, you can do the inverse sine of 1 and you'll get 90 degrees. That's the only solution. Now, in the other cases, when the sine of the angle is equal to a number that's between 0 and 1, then there are actually two, or there are often two possible values. The first one your calculator will give to you when you do inverse sine of 0.5, your calculator will give you 30 degrees. But also, there's another possible answer, which is 180 minus 30, which would be 150 degrees. However, you've also got to then check that this other value doesn't burst the triangle, doesn't make the triangle more than 180 degrees. And we'll see an example or a couple of examples of that on the next page. Okay, so on this page here, we are going to look at this example 2 first of all. So what we have here is a triangle. Now we're not sure about the actual shape of the triangle yet, because okay, we've got that this angle here is 30 degrees, angle A is 30 degrees, and we've got that this side here, B, is equal to 6. And so what we're asked to find out are the sizes of angle B and angle C. Well, it could be, you know, if A is equal to 4, which it suggests in this thing here, this the first part A, it says that A is equal to 4. If A is equal to 4, we could draw A equals 4 in like that, or we might be able to draw A equals 4 in like that. Those will give us two possible values for angle B. And we're going to write down those two possible values in this table for B and B. Okay, so we'll use the sine rule for this. Setting up the sine rule is the easy part. At least we hope it will be the easy part. To find out what angle B is equal to, again, we're just going to do a side divided by the sine of the opposite angle equals a side divided by the sine of the opposite angle. 4 over sine of 30, 4 over sine of 30 is equal to 6 over sine B, 6 over sine of B. We can then rearrange that for sine B. If we do that, what we should get is something that looks like this. So sine of B is equal to 0.75. We can then rewrite that. We can take the inverse sine of 0.75. If we do that, what we should get is 48.6 degrees. Okay, so if we imagine that the angle B is 48.6 degrees, then that's actually this triangle that we are dealing with, the triangle that looks like this, with this angle here being 48.6 degrees. If this angle here is 48.6 degrees, then to find the angle C that goes from all the way from here across to here, that angle is going to be 180 minus 30 minus 48.6. So that's how we get the angle C there. And so our triangle is going to have an angle of B, which is 48.6, and an angle of C, which is going to be 101.4, so that they all add up to 180 degrees. However, that angle B, that angle here that we found, that 48.6, isn't the only possibility. There's also a possibility of this angle here. And of course, since we have what looks like an isosceles triangle here, this angle here is 48.6. So to get this angle here, we just have to do 180 minus 48.6. And that's how we get our alternative value of B. B is equal to 131.4. And that's what this angle in here would be. This angle right in here would be 131.4 degrees. And then if you take that and 30 away from 180, you'll get this small angle here for this triangle. Right? So this triangle is a triangle ABC that would be the second case. So that second case, that second possibility, okay, your angle A is still 30 degrees, but this time B isn't 48.6, it's that other possibility, 131.4. So it's going to be 131.4 for B, and C is going to be 18.6 to subtract those two from 180. Okay, so that worked quite nicely. We got two different possible triangles there. However, in this second example, something else might well happen. Right, so we're asked to also consider what would happen if we had A equal to 7. So if this side here were 7 instead of just 4, like this example here. So again, we use the sine rule. Right? So we're going to use the sine rule again for this. We're going to set things up so that we have the sine rule just as it was before. We've got the 7 divided by sine of 30 equals 6 divided by the sine of whatever this angle here is. If we try that and rearrange it, we will get possibilities. We'll get sine of B is equal to 0.42857. If you do the inverse sine of that, then I hope that we get 25.4 degrees. And if B is equal to 25.4, that means that C must be equal to 124.6 degrees. Now, if we apply the same logic to this as we did to the previous question, then, okay, well, if B is equal to 25.4 degrees, then you would assume that you would be able to do 180 minus 25.4 and get another possible value for B, which would be 154.6. However, if you try and build up the triangle, so if you put in a B of 154.6 degrees, then that means that A and B already add up to more than 180 degrees, so there would be no angle C there. Okay, so this second case is something that's not possible. Right? It's impossible for that to happen. So the only possible value for B would be 25.4 degrees in this case. In this final example, we have a triangle XYZ, and we're given some information about it. If you're asked to find angle Z to the nearest degree, well, we've got angle Y, we've got side Z, and we've got side Y, so we should be able to use the sine rule to solve that. So if we set up the equation like this, we'll get this equation here. If we then rearrange that for sine Z, we get this equation here, which means that sine of Z is equal to 2.3474. Now, if you try to solve that on your calculator, what happens is there are no solutions to that. Right? There's nothing you can do. You can't do the inverse sine of 2.3474 and get a solution. So this information here is information that you can't make a triangle out of. It's impossible.